Fine, we can have a look at the another data structure, which is a map. Okay, fine. Okay, so we can have a look at another data structure which uses two type parameters. A map has two type parameters, k comma v. This we understand is not extending from collection. Right? It is not an extending from collection. An important thing to know about map is map has also got an interface. Map is an interface. It has a sub interface, not sub interface, rather I should say it has a member interface. There is an interface defined inside the map. Okay, so that's an interface called Map.Entry. Again, it also has two type parameters, k and v. So what is a map? What is a map? Okay, map, fine, is a set of entries. Map is simply a set of entries. Okay, entries are of type map.entry. Okay, entry is a key value pair. Entry is a key value pair. Okay, so single key value pair is an entry. Fine, one key value pair is one entry. Okay, I'll explain. See, it's the way you have to visualize is something like this. Okay, see, fine. This is, let's say, a map. Okay, fine. What we have in a map? Entries. So each entry is a key and a value. It has two things. Each entry has two things, key and a value. Key will be of type k, v is nothing but value will be of type v. So we say map of k comma v. Okay, fine. So you can you have multiple entries here. Each entry is a key value pair. Fine. One entry in a map is a key value pair. Okay. So think of this as a set basically. Map is nothing but a set where the entries are of type key and value. Okay. Yeah, set unique. Unique means, okay, a entry is identified by its key. A entry is identifiable by the key. So you can't have two entries with the same key. Entry, fine. Two entries are equal if their keys are equal. Okay, fine. Entries would be considered as equal if their keys are equal. So in a set, sorry, in a map, we can't have two entries having the same key. Okay. Every entry will have a different key. Okay, fine. Let's look at the operations which we can perform on a map. Fine, methods. But okay, before going into the map, let's also look at the interface called Map.Entry. Okay, so just one single entry which goes in a map, what are the operations you can perform on this kind of an object? Okay, there are only few. As these are again abstract methods, right? So we'll have, there are three abstract methods in a map entry. So if I say map.entry, okay, of k and v, two type parameters, key type and a value type. Okay, so this has, since it's an entry, it has two elements, we'll have the get methods for them. So there is a method to return k. Name of the method is get, and we have the method called get key. That would return k. Fine. The other method will be get value. That should return the value part. So once an entry is there, we can get the key part, get the value part, as well as we can change the value. We can't change the key. In an entry object, we cannot change the key, but we can always change the value. Right? So we have a method which returns v. Name of the method is set value. Okay, parameter is of type v, the new value which will be there. What is returned is the old value. So if there is any entry, the old value is going to be returned. And so keep this in mind, that we have a map entry having something like this. Three methods, three abstract methods in map.entry. Okay, fine. So map is nothing but having keys and value, fine, made up of entries. Each entry is a key value pair. Right? So key value is nothing but a mapping of a key with a value. Okay, fine. The way these entries are organized, they are organized in a manner so that it would be efficient to fetch the entry by using the key. Fine. The entries are easily fetchable by the help of the key. If you know the key, you can find the entry for that key. And if you find the entry, you can know the value, right? Okay. So entries are located or organized according to the key. It's a hash table basically, using the hash value of the key. Fine. In a hash table, buckets are used basically, right? So bucket number decided based on the hash code returned by the hash code method of the object class. It's used on the key object, and then it is saying, okay, that's where it should be placed. Okay, so finding the entry with the help of the key is going to be more efficient, right, rather than sequentially searching them one by one. Okay, fine. So this is just to give an idea of this, right? Let's go back and let's list all the methods now. Okay, fine. Again, methods, some of them would be similar to or inspired by the methods of the collection which we have seen earlier. Okay. Okay, so first, methods of this. Anyway, I have written them earlier, but I'll just put them here. Public method, fine, returns a get key. Public method returns v, get the value part. Okay. Public method returns v, set value. Takes v, the new value. Okay, the return value is the old value. So fine. Okay, fine. So this is what we have as the Map.Entry. Now let's look at methods of, I should put this word, abstract methods. Of map. Okay, now we look at map of A comma B. Okay, fine. So keep this in the background, and then we'll see what are the methods of the, how those methods work basically. So yeah, looking at the methods of collection, a method to make an entry. Okay, so yes, we have a method, but the method here, okay, we have this public method to return V. Name of the method is put. Okay, it takes two parameters. First will be of type K, that's a key, and second will be of type V, that's a value. So you specify a key and a value. Okay, so what will be done? It will see whether there is an entry by this key or not, already there in this map. If an entry exists, what will be done? On that entry, it will call the set value method, and whatever it returns, that's returned back to you. Okay, so if I'm saying put and I'm giving a key, if the key was existing, whatever was the old mapping, I'll get the value for that, and the new value is set there. Okay, it's a replacing. If existing, I'll replace the value and give you the old value. Okay, and if it was not existing, create an entry and I'll return a null. Use these two to create an entry and then return a null, because it wasn't existing. There was nothing previously there. Clear? Okay. Fine. So put method is like this. Okay. If you have a put, what else should be there? To fetch. Get method takes the key as a parameter. And give it a key, it will fetch the entry. From that, it will give you the value. Okay. We have another public method to return V. Name of the method is remove. Parameter is key. So what will be done? See, all three are removing the old value. All three are returning the value for the given key. Okay. Fine. So what does remove do? For the given key, identify the entry. If there is an entry, remove the entry. Remove the entry, but from that entry, give the value part. So all three are returning the value for the corresponding key. Okay. Fine. Fine. The first and the third, they are also updating. They are updating the map. Second one is only fetching the value from the map. Fine. So simple operations, right? Okay. What are the other simple operations which we found in the collection? Let's get inspired from there. There was add, equivalent of that would be a put. What was the next? Remove. Oh, we have a remove here. Next, what were the other methods? Not the static methods, the operations on the object. Contains. Okay. So we also here also we have a method to return boolean. Name of the method is contains key, and give it a object. Fine. So it will search whether there is an entry with this key or not, and return true or false. But there's only not one contains, there are two contains method. Okay. You could be searching for, or do we have an entry with a particular value? Of course, this is not going to be efficient. Okay, it will have to go through all of them. Okay, here it could have located just based on the key itself. Right? But anyway, this method also has been provided. So One is a method called contains. What were the other methods in the collection? Yeah, is empty. Okay. Yeah. No entries in this, right? Yeah. What else? Method to return number of entries. Yeah. The size method. Okay. We have the size method. Yeah. And is empty. What else? Contains, is empty, clear. Right? And see, these are exactly what we had in the collection. This is nothing but a set of entries. Okay. You have the size. You have the is empty. You can have the contains, is empty, size, clear, atom. Yeah. Okay. 6 of those. Yeah. So fine. Similar to what we had in the collection. Now let's look at some more methods here. Okay. No, we don't have conversion to an array. Okay. But what you can always do is you can say, okay, let me find out all the values which are there, or let me have, so we have public method. I think we can even go for a set of k. Okay. There's a method called key set. If you say key set, what does it do? Right? Create a set containing all the keys. Looks at all the entries, picks up the keys, and creates a set from that. Keys are unique. Right? Values may not be. Right? So we even have a method, but this method would return a collection of v values. Pick up all the values from across all the entries, pick up the values, and that's a collection because it's not necessarily unique. Okay, fine. We even also have a method to return a set of give me the set of entries. Okay, fine. This method name is entry set. So you get a set whose elements are the entry. Fine. So here you don't have anything to iterate over the elements, but you want iteration. Oh, you can iterate over all the keys, you can iterate over all the values, you can iterate over the entries. Fine. Once you have any of these set or collection or right, you have the iterator method on them. So on that you can do a for each. Okay. Fine. Right. For example, yes, if there is a okay, where we might be using a map, right? Okay, we'll be having one more exercise. We'll have to create one more class now. Okay, later, right? But yeah, what we'll be defining will be there will be a class to be defined. There's a class called bank which has to be created. Okay, and bank will have a what this will contain a private variable which would be a map of long so that we identify by account number. Okay, and the corresponding account object. So organizing the account by their account number. Bank has to organize the accounts by their account numbers, right? Keys will be the account number and you will have the corresponding account objects. Okay. Fine. So we would have this kind of a data structure. And okay, whatever way it may be, right? So we'll see how it is done later. And but we'll have a bank which is managing account by their account numbers. Okay. And then we'll add appropriate methods to the bank also. And we'll think about bank, what kind of methods it should have. Okay, fine. Now, why I have come to this is just to show you that how those things can be used. Or you want to iterate over all the account numbers, right? You can say for each. See, map directly is not iterable, but you can still be using something like this. For each long, or oh, you want to go over all the account objects for each account AC in account map dot values. Okay, account map is not iterable, but account map dot values, account map dot key set, account map dot entry set, that's what you can use the for each with. Okay, you can iterate over all of them. Okay, and you want to do something for all the accounts, and maybe update the interest, fine, apply interest on all the account objects, compute and do something, some operations. Okay, fine. Okay, so when continuing with the other methods of the map, we have the bulk operation. Okay, the bulk operation is public, returns void. What's the name of the method? Put on. And parameter would be map of question mark extends k comma question mark extends b, and the other map. Okay, and putting entries from another map into this. Okay, fine. So these are the abstract methods of the map.